Hi, my dear students. In this video, we are going to discuss top 10 MCQs based on the topic continuous charge distribution and electric field. These questions are selected as per the latest NMC NEET syllabus. Okay, we can start. Question number 1. A cubical block of mass m containing a net positive charge q is placed on a smooth horizontal surface which terminates on a vertical wall, as shown in the figure. The distance between the wall and the block is d. A horizontal electric field E directed towards the wall is suddenly switched on. Assuming elastic collision, the time period of resulting collision is. So, in this question, our target is to find the time period of collision. The situation in this question I have already visualized there. You can see that this block, the mass of that block is m and charge is q. It is placed in an electric field E. So definitely it will be getting a force q into E. The block experiences a force F, which can be mathematically represented as F equal to q into E. Now the target in this question is time period. We have to focus on that point. So, what is time period? Here, time period denotes the time taken by the block to travel up to this wall. This is the wall. Let it be t. Then, after hitting the wall, it is an elastic collision, so no energy is lost. So, the block will come back. So, time taken in the backward journey will also be equal to t. So, the time period, the required time period in this question can be written as capital T equal to 2 times T. So this we have to find. So 2 into T. So we have to find T, small t first. So for that, the force experienced by the block F equal to QE, I have already told you. Now the motion of the block, you can see that it is an accelerated motion. And the motion is also along a straight line. That means acceleration is given by force by mass, which is equal to QE by M. So since this is an accelerated motion and the mass, our block is traveling in a straight line, we can use kinematic equation. So kinematic equation can be written as S equals ut plus half at square. Because we need a relationship between the distance and the time taken. So from the position of the block to the wall, the distance we can take it as d, because in the question already they have mentioned the block is kept from the wall at a distance of small d. So d equals u into t. Here u equal to 0 because a horizontal electric field E directed towards the wall is suddenly switched on. That means initially the block was at rest. So that I am taking u equal to 0. So d equal to 0 plus half into what is A? QE by M into t square. That means t square equals 2md by QE. Or you can write implies t equals root of 2md by QE. Now the required time period can be now expressed as t equals capital T equals 2 into small t, which is equal to 2 into root 2md by QE. When the 2 is taken inside the square root, we can write 4. So 4 into 2, 8 md divided by QE. So our required answer is root 8 md by QE. Third choice is our correct choice. Now we can move on to question number 2. A simple pendulum has a length L, mass of bob M. The bob is given a charge Q. The pendulum is suspended between the vertical plates of charged parallel plate capacitor. If E is the electric field strength between the plates, then time period. So here a simple pendulum, it is kept between the plates of a parallel plate capacitor, and here also they are asking to find time period of oscillation. So in our mind, it should come that time period of oscillation in any situation, generally we can express it as T equals 2 pi into root of L by G effective. Here G effective means effective acceleration. G effective means effective acceleration. Now, from this figure, it is clear that the electric field is acting in this direction from plus to minus E. So, your simple pendulum is kept in between the two plates. And here it is getting deflected through a small angle theta. Theta is not given in the question, I am just assuming. Now, this situation we can visualize separately, then that will be better for our calculation. So, the situation will be like this. So that means our bulb has mass m and it has a charge q also. So its charge, I will write it here. Its charge is q, its mass is m. Now due to the electric field, it is getting deflected. That means it is getting a force q into E in this direction. Because electric field is acting from positive plate to negative plate. So left to right. So q into E. Now its weight is acting downward, mg. So in that bob, two forces are acting, QE towards right and mg in the downward direction. So net force, first we have to think of net force acting on that bob. Net force equals, we can write it as root of mg square plus QE the whole square. So two forces are acting. That means effective acceleration. Always acceleration equals net force by mass. Net force by mass. So what we will get? Root of mg the whole square plus QE the whole square divided by m, which is equal to root of g square plus QE by m the whole square. QE by m the whole square. Now time period. We need the expression for time period. So T is equal to 2 pi into root of L by our G effective or A effective, we got it as G square plus QE by m the whole square. And the whole raised to 1 by 2. The whole raised to 1 by 2. So our answer will be fourth choice. The best matching is fourth choice. Now comes our question number 3. A charged particle of mass m and charge q is released from rest in a uniform electric field E. The kinetic energy of the particle after time t is. So remember, they are asking for kinetic energy of the particle after time t. That means in your final answer for kinetic energy, there should be t. T should be present. Either it can be t square root t by 2. So there should be a connection between kinetic energy and time. That means your kinetic energy should be an instantaneous quantity. Dependency on time means it needs to be an instantaneous quantity. In your final answer, T is required. If you look at the choice also, you can see in all the choices T, small t is present. Now we can come to the basic idea. What is kinetic energy? Kinetic energy is equal to half mv square. Now we need dependence of kinetic energy on t. In this expression, half is a constant, m is a constant. So dependency on time can be made on the parameter v only. Now the particle is released from rest in a uniform electric field E. That means released from rest means immediately you can think that U equal to 0. Now it is released in a uniform electric field. So definitely that charge will be experiencing a force given by F equals Q into E. Now if there is force, definitely there will be acceleration also. What is acceleration? Acceleration equals force by mass, which is equal to QE by M. Now we need kinetic energy of the particle after time t. So that means we need velocity after the time t. So velocity v equals u plus at. Since here also this is an accelerated motion because your charge particle is getting a force, and definitely it will have the acceleration also. So for accelerated situation, for accelerated motion, we can definitely use kinematic equation. That's why I have written here v equals u plus at. Now u equal to 0, so I can write v is equal to 0 plus qe by m into t. That means v equals qe by m into t. So here comes our answer, kinetic energy. We need kinetic energy. What is kinetic energy? Kinetic energy equals half mv square. That means half into m into, what is v square? V is, we have represented here. So v equals, or v square equals qe by m into t the whole square. That means you will get half into m into q square e square t square divided by m square. Now after simplification you will get q square e square t square divided by 2m. So q square e square t square by 2m. So your answer is third option. The best matching option is third option. Now we can move on to question number 4. A particle of mass m and charge q is thrown in the vertical direction with a velocity v0 in a uniform horizontal electric field E. Assuming gravity force to be negligible, the equation of path followed by the particle will be. See, in this question, they are asking for equation of path followed by the particle. In these type of questions, always remember your particle might have displacement in two directions. That means x direction and y direction. So the relation between x and y, that is actually required in this problem. If you look at the choice also, you can see in all the choices there is a relation between x and y. So our target or our focus is to find the relation between x and y in this question. Now come to the situation. A particle of mass m and charge q. Okay, particle of mass m and charge q. Now it is thrown in vertical direction with velocity v naught. Okay, so we are throwing it with velocity v naught in the upward direction. Now at the same time, the particle is getting a horizontal electric field E. That means in this direction, there is an electric field E. So in horizontal direction, if there is an electric field, definitely we know there will be a force in this direction, F equal to Q into E. But in vertical direction, the particle is moving with the constant velocity. There is no acceleration at all. That means in vertical direction, no acceleration. In vertical direction, acceleration equal to 0. But in horizontal direction, there is an acceleration, and we know that acceleration equal to force by mass. What is the force? QE by m. Now, after time t, we always have to think about the position of the particle after time t. So we can think of that situation. After time t, X denotes horizontal displacement or distance traveled by the particle in t seconds in horizontal direction. X equal to, in horizontal direction, it is an accelerated motion. So we can use kinematic equation. Now in horizontal direction, initial velocity is 0. That means you can use the concept of S equal to ut plus half at square. So 0 plus half into a into t square. That means x equals half into what is acceleration qe by m into t square. Let it be equation number 1. Now in vertical direction, what will be the displacement? So after time t, displacement in vertical direction, I denote it by y. So what is y? In vertical direction there is no acceleration, so there is no need of using our kinematic equation. So the particle is moving with a constant velocity v naught. So y, distance equal to speed into time, we can use that concept. So y equals v0 into t. Or we can label it as equation number 2. Now from equation number 2, I get it as t equal to y by v naught. Because in this question, we need a relation between x and y. So let it be equation number 3. Now put 3 in 1. Put 3 in 1. Then what we will get? X equals half into qe by m into t square. In the position of t square, you can substitute y square by v naught square. So this is the equation of a parabola. So the best choice is x equals qe by 2m v0 square into y square. First choice is the correct answer. So now comes question number 5. A pith ball carrying a charge of 3 into 10 raised to minus 10 coulomb is suspended by an insulated thread of length 50 centimeter. When a uniform electric field is applied in a horizontal direction, the ball is found to deflect by 2 centimeter from the vertical. If the mass of the ball is 0.5 gram, the intensity of electric field is. So here they are asking for intensity of electric field in this situation. Now we can go to visualization of the situation given in the question. That's very important. So a pith ball is hanging or suspended by an insulated thread of length 50 centimeter. We can visualize that concept. So pith ball situation will be like this. It's a pith ball. And it has a mass and it has a charge also. So I am denoting it generally here. Mass m and charge q. Two parameters are given. Now they are given an electric field E. Question is like that. When a uniform electric field is applied in a horizontal direction, so that's why I have shown here. In this situation, the pith ball got deflected, and the deflected position I can draw like this. The deflected position. Now here it is your mass m and charge q. Pith ball is at this position now. Let the angle here is theta, and this distance is given as 2 centimeter. 2 centimeter from the vertical. This is the vertical line. So 2 centimeter from the vertical. Now intensity of electric field they are asking. Now this distance is 50 centimeter because length of the thread, insulating thread, is 50 centimeter. Now the situation of this, I can mark the components here. Here, what are the forces acting on the pith ball? We can look into that. The forces acting are, definitely its weight will be acting in the downward direction. Mg will be acting in the downward direction. And due to the horizontal electric field, it is getting a force in this horizontal direction. And we all now know that it is Q into E. Now, apart from all these things, there is tension in the thread. It can be denoted by T. There is tension in the thread. That tension can be resolved into two components. What are those components? One component is T cos theta. T cos theta. Because here comes the angle theta. So T cos theta in the vertically upward direction and then T sin theta in this direction. T sin theta. T sin theta. And the pith ball will be in equilibrium. So equilibrium means forces acting on that object are equal in magnitude and opposite in direction. We have to keep that concept in mind. So I am equating the vertical forces. What I will get? I am going to get T cos theta equals mg. T cos theta in the upward direction and mg in the downward direction. Now horizontal direction I can write T sin theta equals q into E. So this is equation number 1 and this is equation number 2. Now take 2 by 1. So that we get tan theta equals QE by mg. Our target is to find E. Now tan theta, as theta is very small, tan theta approximately equal to sin theta. We can make an approximation like that. Because from this triangle, it is easy to calculate sin theta. So what is sin theta from that triangle? So sin theta equal to opposite side by hypotenuse. That means 2 by 50. So you can write sin theta equal to QE by mg. Now again, which implies sin theta equal to 2 by 50. So 2 by 50 is equal to QE by mg. Now from this, we will get the value for E. Because all the other parameters are given. What is E? E equals 2mg divided by 50 into Q. All the values are given. 2 into, what is mass of pith ball? Mass of pith ball is 0.5 gram. So 0.5 into 10 raised to minus 3 kilogram into 10. G, the value of G I took it as 10. 50 into, what is the charge of the pith ball? 3 into 10 raised to minus 10 coulomb. 3 into 10 raised to minus 10 coulomb. So after simplification, you will get the value as 6.6 into 10 raised to 5 Newton per coulomb. So the choice is, first choice is our correct choice. Now we can discuss question number 6. A circular wire loop of radius A carries a total charge Q distributed uniformly over its length. A small length dl of the wire is cut off. The electric field at the center due to the remaining wire is. So, electric field due to remaining wire at the center. So, we can visualize the situation. So, this is a circular wire loop of radius A. Circular wire loop. In this circular wire loop, a small portion you have removed. That length is given as dl. That length is already given in the question as dl. So I am marking it here dl. So corresponding to dl in this part, actually it is a charge was initially uniformly distributed. So charge uniformly distributed means the concept is that initially the situation is like this. So charge is uniformly distributed. That is the main point given in the question. The radius is A. So charge is uniformly distributed means at each and every point charge density will be same. Now, here, due to symmetry, because charge is distributed uniformly, so due to symmetry, we can say that electric field at the center will be 0. E at the center point, if the center is denoted by O, E at the center is 0. But in this situation, or at this condition, you have removed a small portion of length dl. So charge, what is the charge present in this dl length of the wire? That we have to think. For that, it is very easy. Let the charge is denoted by dq. Then I can write like this: dq equals, see, this is a circular wire loop. Its total length is 2 pi a. So on total length 2 pi a, the charge uniformly distributed is q. So 2 pi a length, so for 2 pi a length, there is charge q. Now for the dl length, the required charge is dq. So the charge dq can be easily found as dq equals q by 2 pi a into dl. Now the concept is like this. It's very interesting. So electric field due to the small length dl plus electric field due to the remaining portion, the remaining part, was initially equal to 0. That means before cutting, this was the situation, that electric field due to that small length plus electric field due to remaining length was equal to 0. Now you removed a small portion. And in this question, they are asking to find electric field due to remaining length. That means electric field due to remaining length is equal to minus of electric field due to that small length dl. Now, electric field due to that small length dl can be easily calculated as electric field due to dl equals 1 by 4 pi epsilon naught into dq by a square. This is our basic relation. dq denotes charge due to that small length, which we have already calculated here. Now, that means electric field due to dl equals 1 by 4 pi epsilon naught into, what is dq? q by 2 pi a into dl. Again into 1 by a square. So what will be your answer? Electric field due to dl will be equal to q into dl divided by 8 pi square epsilon naught a cube. Now in this answer choice, actually electric field of the remaining portion equal to minus E into dl. Here no need to take the negative sign because we need the magnitude only. That means you have to consider in this way only. Electric field due to remaining portion, modulus of electric field due to remaining portion is equal to modulus of electric field due to that small length dl. That means our choice will be first choice here. But here there is a small problem in the choice, that pi square is missing there, but actually pi square, I will add here pi square. So your first choice is the correct answer to this question. Now comes question number 7. A positive charge q is placed in front of a conducting solid cube at a distance d from its center. The electric field at the center of the cube due to charges appearing on its surface. So this is a very interesting question. You see here, there is a cube, and from the center of the cube at a distance d, a small positive charge q is placed. And they are asking for electric field at the center of the cube due to charges appearing on its surface. Now, see here, this is a conducting solid cube. That's the first information we have to look into. Now, when you place a plus q charge here, at this face, negative charges will be induced. This is the near end. We can say this is the near face of the cube to the charge q. So in this phase, negative charges will be induced. Correspondingly, in this phase, positive charges will be induced. Positive charges will be induced. So this is connected with induction, charge induction process. Now what happens is that from this phase, from the positive charged phase to negative charged phase, there will be an induced electric field. There will be an induced electric field. Now, due to this charge Q, at the center, there will be an electric field. Let it be denoted by EQ. And it will be in this direction, EQ. Electric field due to charge kept at the outside of the cube. Now this is a conducting solid cube. So conducting solid cube means immediately the idea should come to our mind, inside a conductor electric field is 0. So E inside equals 0. Now what is E inside? E inside is E induced plus EQ, which is equal to 0, because these two electric fields are now existing inside the cube. Both of them should cancel each other. E induced plus EQ equal to 0. In other words, we can write, see, all these things we have to represent it in vector form. So E induced plus EQ equal to 0, or you can write E induced equals minus EQ. Now we need the magnitude only here. So mod E induced equals mod EQ. Now we have to find E induced. In this question they are asking for the electric field at the center of the cube due to charges appearing on its surface. Charges appearing on its surface means they are referring to induced charges. Induced charges. So we have to find electric field due to induced charges, and that is equal to electric field due to charge kept outside the cube. Now at the center of the cube, what is the value of electric field due to this cube? That we can apply the basic relation 1 by 4 pi epsilon naught into Q by d square. So electric field inside the cube due to this charge Q, the general principle I have applied, E equal to or EQ equals 1 by 4 pi epsilon naught into Q by d square. So our answer is first choice. Our answer is first choice. 1 by 4 pi epsilon naught into Q by d square. Okay, now we can move on to question number 8. What is question number 8? 64 drops of radius 0.02 meter and each carrying a charge of 5 microcoulomb are combined to form a bigger drop. Find how the surface density of electrification will change if no charge is lost. So 64 drops are combining to form a bigger drop. So in this type of questions, first idea, first concept that should come to our mind is volume conservation. Now what is volume conservation? Volume conservation means total volume before combining equal to total volume after combining. So in this situation 64 drops are combining. So volume of 64 drop is 64 into 4 by 3 pi small r cube. Because all drops we assume the shape as spherical shape. That's why I took the volume as 4 by 3 pi r cube. So 64 into 4 by 3 pi r cube, and after combining they form a bigger drop of radius capital R. Then I can write the volume as 4 by 3 pi capital R cube. Now cancelling common terms on both sides, 4 by 3 pi, we get a relation. What is the relation? 64 r cube equals capital R cube, which implies that your capital R equals 4 times small r. This result is needed for us. For that we have took the concept of volume conservation. Now come, they are talking about surface charge density. Find how the surface density of electrification will change. That means before combining and after combining, what is the variation in surface charge density? That's they are asking. So sigma initial, I am denoting it by sigma I. So charge density equals charge by area. So the charge is initial charge on one drop. One drop. Initially 64 drops are there. Each drop contained 5 microcoulomb charge. So we can write sigma I means in one drop there is 5 microcoulomb charge only. So charge by area. So charge by area. What is charge on a single drop? 5 microcoulomb. So 5 into 10 raised to minus 6 divided by what is area? 4 pi small r square. Now after combining you are getting a bigger drop, and in that case the final charge density is given by. Now after combining all the charges are coming to a single drop. So total charge is 64 into 5 into 10 raised to minus 6, because 64 drops are combined here. So the total charge becomes 64 into 5 into 10 raised to minus 6 on the bigger drop divided by area, because these are spherical drops. So surface area is 4 pi r square. Here you have to take capital R square. So equation number 1 and equation number 2. Now we have to take sigma I by sigma f. That is required in the question. So sigma I by sigma f. What we will get? We will get it as, on simplification, we will get it as r square by 64 r square. That means r square is 4 or 16 small r square divided by 64 r square. That means 1 by 4. So your answer is option 3. Okay, now it's time for 9th question. If the Earth's surface is treated as a conducting surface with some charge, then the order of magnitude of the charge per unit area sigma in coulomb per meter square, so that a proton remains suspended in space near the Earth's surface will be. So here they are asking for an expression for sigma, charge density on Earth's surface. Now in this question we have to just visualize the situation. So let this be our Earth, and near the surface of Earth a proton is suspended. Proton is suspended. Now I can draw it clearly. Let this denotes the proton, and mass of the proton is given in the question as m. Mass of the proton is given in the question as m. Now Earth is a conductor. If Earth's surface is treated as a conducting surface, that's the information given in the question. So we know that near the surface of a conductor there will be an electric field, and the value of that electric field is given by E equals sigma by epsilon naught. That means on this proton there will be an electric field acting on the proton in the upward direction. Electric field. Now its weight will be acting downward, mg. In this question, the requirement is that a proton remains suspended in space. That means proton is in equilibrium. That means the situation is like this. Your proton is here, mg is acting downward. Due to the electric field in the upward direction, it experiences a force in the upward direction given by E. The charge of a proton, I took it as, not I, it is given in the question. It is E. I took it as E. So mg equal to E. That is the equilibrium condition here. This is our Earth. So I can write mg equals E. Now Earth is treated as a conductor, so electric field I can replace it by sigma by epsilon naught. So mg equals E into sigma by epsilon naught. and we need the expression for sigma. So what is sigma? Sigma equals mg epsilon naught divided by E. That means our correct answer is option 2. Now we are moving on to last question of this video. Three concentric metallic spherical shells of radii R, 2R and 3R are given charges Q1, Q2, Q3 respectively. It is found that the surface charge densities on the outer surfaces of the shells are equal. Then ratio of charges given to the shells Q1 is to Q2 equal to Q3 is. So here, metallic spherical shells, we can visualize the situation. This is an interesting question. So three concentric means all of them have same center. So three concentric. Now one more is required for our purpose. I am drawing it here. So these are the three concentric spherical shells. So I think it's the time to mark the radius. This is R, this is 2R. Okay, I have to wait here. So this is R. First one, this is our 2R. Why it is coming like this? Okay, I have to just draw it like this. Now comes the third one, 3R. It will be better. So R, 2R, 3R. Now the charge is given as follows. That we have to concentrate. How the charge is distributed. On the surface of first shell, the charge is Q1 given. On the surface of second one, the charge given is Q2. And the third one, it is given as Q3. Now, we have to consider induction effect here. It's very easy to think of that. Induction effect. So here Q1 means, here it becomes minus Q1. Now here it becomes plus Q1. Now here, what is the total charge? Q1 plus Q2. Due to induction on the surface of the second shell. So if you want, I can label it. This is the first shell, this is the second shell, and this is the third shell. So the surface of second shell, the charge becomes Q1 plus Q2. I will write it separately here. Q1 plus Q2. Now what happens is that when Q1 plus Q2 comes here, here the induction effect comes. So here it becomes minus of Q1 plus Q2. Positive charge induces negative charge. Now here minus Q1 plus Q2 means at the outer side it becomes plus Q1 plus Q2. So total charge on the surface of the outer sphere becomes, I will write here, Q1 plus Q2 plus Q3. So this concept should be very clear in your mind. Induction effect. So this is one value. This is the charge on the surface of second one. And this is the charge on the first one. Now, according to the question, charge density on the surface of three spheres are equal. That means straight away I can write sigma 1 equals sigma 2 equals sigma 3. Now what is sigma 1? Sigma 1 is charge by area. So I can write Q1 by 4 pi r square. 4 pi r square, which is equal to Q1 plus Q2, because on the surface of second sphere, the total charge effect is Q1 plus Q2. So Q1 plus Q2 divided by 4 pi into 2r the whole square. Now which is equal to third sphere. Charge density is Q1 plus Q2 plus Q3 divided by 4 pi into 3r the whole square. Now, after cancelling the common terms, what we will get here, it is 4 pi, 4 pi, 4 pi. Then we will get it as Q1 equals Q1 plus Q2 divided by 4, which is equal to Q1 plus Q2 plus Q3 divided by 9. Now considering first two parts, I can write 4q1 equals q1 plus q2. Or in other words, 3q1 equals q2, which implies q1 by q2 equals 1 by 3. Let it be there. Now we can take the next part. That means these two parts, q1 and this relation. So what you will get? 9q1, or I think it's very easy if you take, okay, 9q1 equals, now q1 plus q2, already we got it as 4q1. I am going to substitute here. So 4q1 plus q3 divided by, divided by is not required because already we have taken that 9 separately. So 9q1 is equal to 4q1 plus q3. That means 5q1 is equal to q3, which implies q1 by q3 equals 1 by 5. Now two results we got now. One is q1 by q2 equal to 1 by 3 and q1 by q3 equal to 1 by 5. Now when we combine these two results, we will get q1 is to q2 is to q3 equals 1 is to 3 is to 5. So our correct answer is 1 is to 3 is to 5. Okay, so this is the end of our video, this session's video. So all of you please go through the questions and solutions and do it repeatedly so many times. Okay, thank you.